Hello and welcome to a new video here on my channel here at commaik, all about lawn and garden irrigation. I'm currently setting up a new irrigation system here on this lawn, and in this short segment I'd like to show you which components I'm using for it. I've prepared a small section here for you so you can see exactly what's being installed. You'll find all the details in the video. Stay tuned, let's get started. In the last video I showed you how I planned my new Hunter MP Rotator lawn irrigation system. In this video I'll show you which components I use for it. I'll show you the distributor, the valves, the connectors, the pipes and the tools you need for it, and of course the blowers and the individual nozzles. For this I'll take you to my workshop. Welcome to my workshop. As you can see, I've set up two different distribution stations. The difference is that the outlets are equipped with an external thread and one with an internal thread. This is basically interesting when it comes to the further setup. If you want to meticulously build the entire thing with this particular head station, you will definitely need a suitable adapter from inch to inch so that everything can be properly and securely assembled onto the main piece. I'll continue with the distributor station with the internal threads. I'll set this variant aside, I need it somewhere else. When ordering the materials, make sure that all components are compatible. The special thing about this distribution station is that when a component is connected here and it's installed in the ground or in your valve box, I'll demonstrate this very briefly by simply screwing this valve on here. And then push this section back. These connectors are flexible and still watertight. The advantage is that if you want to replace components in the middle, you don't have to pull back the following pipes one by one. Because most of the time that's not possible since it's installed in the ground. There are various extensions for this distribution station. For example, an angled piece that can be screwed directly onto this side, also with the flexible back and forth slider. On the other side, there's also a 1-inch thread which would fit here, for example. Or also here at the front. This end cap is also useful. You can put it on the end, for example. The cap has an integrated sealing ring. That means when you tighten it by hand, it's already sealed. You will only need to use sealing tape, for example, a specialized type of Teflon tape, just like this particular one shown here. This head station is placed like this on the ground. From here, water comes in on the right side. Here's the inlet. On the other side, the pipe goes directly into my slope, which I want to water separately later. Such a construction is also used there. This allows me to make the connection for the pipe on the inlet side. Here is a 1-inch thread, which is sealed directly with a sealing ring. You can use a fitting like this directly. These components are loosened slightly, the pipe is screwed in, pushed through to the stop and then tightened again. Thanks to the built-in sealing ring, the whole thing doesn't need to be sealed separately. Usually simply tightening it by hand is enough to ensure a secure seal. The pipe from the inlet is now mounted on this side. On the other side, I want to connect it to my slope. But I want to keep the option open to direct the water here. Because the slope isn't finished yet, I don't know when I'll get to it. And perhaps there are several other compelling reasons to consider installing a stopper in this particular location. Indeed, there are various different options available for this specific purpose. Personally, I acquired a model that features a significantly strong flow reduction capability, which was a key consideration for my needs. I'll swap that out before installing. But I still want to show it to you. Because these adapters, these nipples, from 1 inch to 3/4, have their own appeal. In this particular case, I can simply screw it very tightly and there is absolutely no seal included with this component. I can, however, easily put a suitable seal here, or alternatively, I can effectively seal this end piece with the appropriate sealing thread or perhaps even some high-quality Teflon tape. This meticulous approach ensures that the entire assembly ultimately stays completely leak-proof and secure for a prolonged period. The complete installation within my water box system will appear precisely like this. I possess the inflow connection located here and the outflow connection positioned over here, which I am able to effortlessly open or securely close by utilizing this convenient tap. Should I encounter difficulty in locating a perfectly suitable tap, I also have the option to employ a robust valve, much like this particular one. The truly peculiar aspect is that these specific valves typically do not incur a greater expense than a proper, high-quality tap, and they can be operated with remarkable ease using the clearly visible knob situated on their top surface. This option is quite interesting. I don't know if there could be any long-term damage. If you know anything about it, just let me know in the comments below if you've had any problems with it. I'll now continue with the outlets of these three pieces. This outlet will run out of the valve box, will bend to the right, then it will run under this bore and supply both my garden house and my raised beds with water. In this case, I only need a transition to a 25 PE pipe, one that I've already installed here. It's also installed here. At this point, the PE pipe is connected. With an elbow fitting, I can then route the pipe around the corner. The pipe is already in my valve box, so I just need to connect it. The water circuit is connected to the middle outlet for my new water supply. Here, I first need a valve that can be opened and closed via my control computer. After that, the transition is made to the pipe system and finally to the jumper. For the valves, I ultimately chose the models from Hunter. With these models, I find the big advantage compared to the Rainbird models is that manual opening is relatively easy, requiring just 2 fingers on this solenoid head. I also use the Rainbird models in another valve box. These valves work absolutely perfectly, I really can't complain, but manual opening is very, very difficult. You really need all your strength. I don't want to say that I'm a weakling, but it's not that easy when the valves are installed somewhere in a corner. And you just want to open the whole thing for testing purposes. It's much nicer when everything operates easily and smoothly. With these valves, I also have flow control as well as venting. That means I can adjust how high the water flow should be on these valves. By the way, distributor station, connections, valves, jumper, and so on. You can find all of this in the description below the video. Just take a look there. You can conveniently order everything. Same price for you, a small commission for my channel, so that I can keep making videos like this for you in the future. Back to the valve. It shows you the direction of the water flow. The water has to be brought in on the left side and runs out on the right side. So I just screw the whole thing on with this union nut. I don't need to seal anything with thread or anything like that, thanks to the sealing rings. Now I've connected the valve. I've closed the valve for now. You can see it very clearly here, on, off. If I want to open the valve, half a turn with 2 fingers is enough. The water flow is already established. There should be a connection over here, which leads into my second valve box on this lawn plot. From this valve box, a pipe system runs underground and beneath my G-wig. With this, I want to water the other side of my entrance in the future. There should only be a pass-through here because the tap sits on the other side. But since I haven't gotten that far yet, I have several ways to limit the whole thing. I can simply close off this area, for example by using a double nipple like this. I screw it in here. Here you can clearly see that a robust sealing ring is already securely built in and integrated, not on the other side. Since there's a sealing ring here, it makes sense to screw the side without the sealing ring in by hand until it stops. On the other side, there's a closure cap in the right size. That's this one, which I showed you earlier. It also has a sealing ring. I can screw it in until it stops. If you don't have an original cap, there are also built-in caps without a sealing ring, which would be closed off with this separate rubber ring. Alternatively, you can also use the large sealing ring. Or you can combine the whole thing with different nipples. However, please keep in mind that the space in your valve box is limited at some point, and you'll want to work in this confined space during installation, and possibly later on during a conversion or repair. In this case, everything is almost finished here at the distribution station. The water comes in here on the right side. It is distributed over the 3 outlets, and is also distributed over the 4th outlet, which is currently positioned above this slider. There is a cap on the 1st outlet. This means that water can no longer flow through here. At the 2nd outlet, there is currently a valve which is also closed. Water does not pass through here either. At the 3rd outlet, there is currently a fitting which transfers everything to my pipe system. In another valve box directly at the animal house, at the garden house, at the raised bed. There is already an end piece mounted on the pipe so that the water can remain in the pipe but cannot run out. Speaking of running out, at this point, a note from my side. As you can see, I have no way to drain the water in this setup. I have neither a drain funnel nor a blowout valve, nor do I have a drain valve or anything similar installed here. In autumn, I basically do one thing for all my rainwater systems, as well as for the water pipes that are outside the house. I have a nipple at the central access point to which I can connect my compressed air compressor. This compressed air compressor is activated individually for each water circuit I use. This is how the water circuits are blown out. This means if I want to blow out the water circuit for this distribution station, the air enters the pipe system about 10 meters from here. I open the valve here and the air flows through here. At that moment, I can completely push the water out, ultimately through the nozzles. For this reason, and you'll see this later during installation, I don't install these pipes that deep. Here, I'm in the area of my valve box, but the other pipes are also only buried about a spade's depth. Because with this blowout method, which I've been using for many years, I haven't had any problems so far. I'll keep it that way. So how does it continue from here? At this point, and I'll slide the whole thing back a bit, the valve transfers the water into the pipe system. To connect everything, I use, as you probably know, the Gardena quick connectors. But you can also use the standard fittings for water installations and similar things. In this case though, I have to say I find this system much more convenient, especially in corners that are very narrow and tight. The whole thing can be installed beautifully. You give it a half turn, insert the pipe, then another click. About 1-2 cm, you'll notice it. Then you close it with another half turn, and the whole thing is sealed. In this case, there's even a sealing ring built in here, so I can screw this fitting on directly here and can use the water pipe at this point. With the water pipe, I've already prepared everything once. Here I have a small end piece. You have the option to go directly into the jet at the end using such an angled piece. It has a 0.5-inch male thread connection. With this male thread, you can go directly into the jet, which has a 0.5-inch female thread on the underside. Very important, no Teflon tape or anything similar is to be used here. The manufacturer explicitly states this in their instructions. There is a significant risk that the chemicals could react with each other, clamping on Teflon tape or thread tape, which you can usually buy in the high-priced segment of LR. Does not cause any problems here, but it's purely a precautionary measure. In the worst case, you open the valve and the whole thing leaks a little here. A few drops spill out, but that only happens when water is shooting out up here by the liter. And then those few drops down there don't matter at all. With the screw in, open it half a turn, insert the tube, push it in, close it half a turn, and the whole thing is already installed. This piece corresponds to what I just showed you. The installation is done with the corresponding tube length, of course half a turn on, The entire assembly is carefully pushed back until it reaches the stop and then given precisely half a turn. And this area is already sealed. It's closed. Now the whole thing can get started here. This is what the whole thing looks like. What can happen now, of course, is that if you lay your tube in front of you, the position of the jet doesn't quite line up with the tube. The tube is relatively stiff. I recommend that before you start laying the tube, first take the tube bundle. Usually it's rolled up in a large coil. Put it in the sun, try to unwind it a bit, then it will be a bit easier for you. But if you want to be absolutely sure, then you can use a flexible adapter like this. These components can be bent and have two external threads, connections. And here, of course, one thing is very, very important, which I would also like to show you. Please pay attention to the correct thread sizes. The housing that I use is the pressure regulated housing. In my opinion, it absolutely makes sense to spend a little more money and have less work here when adjusting the regulator. These robust housings have a standard half-inch thread securely on the underside. The fittings I use, however, have a 3/4-inch thread. Now I'm trying to find one. A 3/4-inch thread. And that means you have to be careful that you have half an inch on one side. You see, the whole thing can be turned however you like. If the pipe is lower or higher, if it is bent or angled, with these flexible end pieces, the whole thing is a bit easier. Alternatively, there are also hose systems where you have to buy these angled pieces individually. Here you have a special piece of pipe or hose. Attention, this is not a garden hose. This hose must be pressure resistant, both from the inside when it comes to water pressure, but especially from the outside because the mass of earth presses on it. You may have stones in the ground, the earth shifts, the whole thing should last for years. So use the original pipe or hose, and please, please, please do not use a regular water hose. On the other side, the 3 to 4 inch thread on my Gardena quick connector. If you want to build a system that does not work with the PAS 40 sprinklers, but for example with the i20 gear-driven sprinklers, then you have to make sure that the gear-driven sprinkler has a 3/4 inch thread on the underside. In this case, you would have to use an adapter, which doesn't make much sense if you have the option to buy the correct flexible end piece. 3/4 inch to 3 to 4 inch. The whole thing may sound incredibly complicated, but it isn't. My recommendation, look below the video. There I've linked the products for you with a corresponding short description. If you like, click through there, take a look at everything on Amazon. There you can also see the pictures, and then I think you'll understand what I mean. I'd like to show you everything again. Here you have a flexible end piece. I just found that 3/4 inch to 3/4 inch, and that would fit directly into this i20 transmission trap, because you can see the opening down here. It's significantly larger, 3 to 4 inch. Just screw it in. And then, in addition to that, you can also work with the much larger and more substantial traps. To make working on the pipe system easier, it's recommended to use pipe pliers and pipe scissors. Anyone who has been watching my videos for a long time will know Mike never used pipe scissors. He used a regular sturdy pair of garden scissors. Yes, I did, and I could still do that today. It works. What also works? If you find a good pair of pliers somewhere on sale, whether you can use them in a professional setting, I dare to doubt that. For my purposes, it's enough. Under the video, I'll link you to a professional model if you want to do more work. But in the following, it has the big advantage if you're working on the pipe system and want to make a straight cut. With garden scissors, the whole thing can end up crooked and uneven. You need a good feel for it. And you have the problem that the cuts aren't really clean, that there's usually a small scratch on it, which then has to be scraped off with a utility knife or with a round file. With a pair of scissors like this, you make your mark, snap the whole thing through. At some point, the whole thing is already inside. And with a single decisive push through, the entire thing is completely cut off, effectively and efficiently. And you see, I have a clean cut here, no burrs, and can connect the whole thing directly to the fitting. Before I show you how to install the nozzles, here's a quick note of my own. Down here you'll find the link to subscribe to my channel, which you should do now. If you haven't already, I would really appreciate it. And at the same time, you have the advantage because you'll be notified about every new video. Furthermore, it would be absolutely great if you like this video and also get something out of it. Give me a thumbs up. That would be really great. It would help me and my channel move forward. I'll make a little space for myself and show you the nozzles, or rather how to install the nozzles. The nozzles that I use, as I already mentioned, are the models for rotators with a built-in pressure regulator. With this model, 2.8 bar is output here, no matter how high the input pressure is. Of course, the input pressure must be at least 2.8 bar. If you only connect a small line with an input pressure of 2 bar, you can't expect to get 2.8 bar here. The nozzles are connected from below, as I have already shown you, and here at the top, the nozzle head pops up, and depending on which nozzle is installed, a rain pattern is created. The special thing about these models, compared to the transmission sprinklers, is that the nozzle is always visible. Here the nozzle is hidden. To install the nozzle, you pull up this protective cover. So you can see the nozzle head here. There are special brackets that permanently secure the nozzle head. This can also be done by hand. It's much easier than with the i20, where you have to use a lot of force. As you saw, the nozzle head breaks off relatively quickly. That's actually intentional, because the water should flow through here if no nozzle is installed yet. In this case, I just turn it off. You can see I could screw the protective cover back on. It has a thread. This is where the nozzles are installed. Here I have a nozzle, the MP 2000 nozzle, from 90 degree to 210 degree. You can see that on the collar ring, in this case silver. It has an internal thread which fits directly onto the nozzle. It's screwed on by hand. I can close it again. MP 2000 corner model. MP 3000, the 1000, the 800 series and so on. You can recognize the model from a distance. If you look at the nozzle head, the colors are always consistent. By the way, what I still find absolutely great is the fact that I can use another nozzle manufacturer. I'll get my setup back. Here you can see that the nozzle head, which I used here, looks different than this one from the MP Rotators. If you watch my videos, you know the video, MP Rotator vs Airvan. These two nozzles from the two premium manufacturers, I compared them in this video. At the top right, you see the video, the link, or in the description. There you can see the comparison of the two models. Which model has which advantages, which disadvantages? How is the throw circle? How is the water supply? And how is the handling? One thing is clear. The Hunter models, in my opinion, and this is subjective, have a better spray pattern. But the Rainbird models don't need a separate nozzle for every distance, every angle and so on. These nozzles are much more flexible. With these nozzles, you can adjust a much greater length a much greater angle. There isn't much variation, and you can plan ahead. Furthermore, the nozzle can be adjusted completely without tools. When the system is running, it's totally random, but especially when making adjustments and during the first weeks after making adjustments, you walk while the system is running across your walkways and realize the Rainbird doesn't run perfectly. Here it's really well done. You go there, turn the head, turn the lower part, and can adjust the throw angle completely without tools. With the MP Rotator, it's not like that. It's possible to adjust the system using the silver ring. You need a bit of skill, but it is possible. When it comes to the water flow, the throw distance, you have a micro screw, as I would call it. For this screw, you need a screwdriver. Everyone has a screwdriver, but Hunter wouldn't be Hunter if they couldn't make money from it. Just like with the i20, with the Rainbird, there's a special key. On the top of the key, there's a screwdriver that fits directly into this opening. Then you can adjust the throw distance. Furthermore, there's this ring with the toothed ring in between. You put it on and adjust the throw angle. It's well thought out, and you can make money with it. It's also possible with a small screwdriver that you might already have. You can also adjust the wheel by hand, but the tool makes it a lot easier. I've installed the 2000 nozzle. I can connect it to the pipe system. To do that, I have to get the pipe system into the ground. I'll do that now. The video of the installation you won't see now. This video will be published shortly. It will be a separate part to this project series, to this whole project to build my lawn irrigation system. I hope this part was informative for you. Give me a thumbs up, share this video, check the description below. I've included a lot of links to the products, to the specifications from the manufacturers. I'll show you the links to the other videos I've made, from the calculation to the connection to the comparison of the two models. And of course the Amazon shopping list. If you like it, click on it, support me by doing so. I would really appreciate it. If you like it, leave me a comment below. Give me some feedback. How did you implement it? What did you pay attention to? What should I pay attention to? Write it in the comments below. That would be great. I hope to see you again in the future when I show you the installation of this system in the lawn. Until then, take care. Bye.